So dear students, now let us solve these questions regarding modes. So recognize the modes. So first one, this is the question, first one, and this is the first one. Actually, TE modes and TM modes. First, you take this as a waveguide. That means it is like this. Of course, this end is open, and now what you do, for excitation purpose only, they will close this, they will make it a short circuit here. Short circuit means conductor surface. So if this is conductor surface, then what they do, they take this, and here this coaxial cable is there, short name is coax, it is called as like this, it is then it is coming like this inside, and then it is drilled hole here, then it is inserted here, it comes into the waveguide like this. Then this tip is a conductor, that conductor is called antenna probe, that starts sending the energy. It is drilled here hole, it comes and it looks like this. So that is antenna probe. Okay, and if you want this is a T10 mode. If you want 20 mode, one probe here and another probe here, like that modes, one probe and second probe also here, like this you put one probe here and second probe here you put, then that becomes a TE20 mode, like that. So if you insert in this side wall, then it becomes TE01 mode, like that. So dear students, now how you recognize the modes? Actually I told you M is equal to 1. M is equal to 1 means half wave length in x direction. That is the meaning. Already you know the meaning. Similarly, n is equal to 1 means half wave length in y direction. That is the meaning. Right. I was telling you, if there is a half wave like this, this is the full wave. If you take mod, then it is shown like this and like this. And this is shown like this, students, here like this, and like this. It is half of the wave, sinusoidal. Again it keep going like this value, like this, like this. And what they do, they show this here. Some books they show like this, sinusoidal. In some books they show this one like this, like this. This half cycle, just one line in some books they put, or some books they put two lines. This is half cycle. Then for this half cycle they put like this. So if arrow mark is changing direction, means it is going to next half cycle. For example, this is half cycle, half wavelength. This is a half wavelength. So for this it is shown the lines like this. For this it is shown like this, bottom side. So here students, here you can see, this is the discussion. Here you can see this is A, that means x direction. Here only two lines are shown like this, means that is half wavelength. M is equal to 1. In this direction there are no lines like this. So here n is equal to 0. So this mode is TEMN mode. So that means TE, M value is 1, N value is 0, that one. You can see here, this is x direction, means M values you have to count. Y direction means N value you have to count. So here two lines like this, means that is half cycle, that is up direction, and down direction. So half wavelength and half wavelength. So that is M is equal to 2. Here there are no lines, so N is equal to 0. So mode is TEMN. M is 2 and N value is 0, student, here. Similarly here there are no lines like this, that means M is equal to 0. Here N is equal to 2, because there is there are two lines like this, that is one half wavelength. Again there is a sign reversal, SIGN, sign reversal, otherwise direction reversal. For this up, for this direction is reversed. So that means n is equal to 2. Mode is TE MN mode. So TE M is 0, N is 2. I was telling you, I wrote electric field configuration like this, if you remember. So these are electric field lines. Now have you seen, students, here for 10 mode, 20 mode, 02 mode, that means if M0 or N0 one of them, then electric field will have only maybe X component, electric field X component, or otherwise maybe only electric field Y component. For example, we have discussed for this, in this case, if you see electric field X component 0, electric field had only Y component. So that's why electric field is in Y direction. And if you see this mode, for this electric field X component will be present. That is why electric field directions are in X and Y direction here. No, electric field is in X direction actually. Now TE11 mode, if both are present, like M also not 0, N also not 0, then electric field X component is also present, then electric field Y component is also present, then for that case you see this type of electric field configuration, right? Because for one case you will have a sine, for other case you will have cos. If you take square and you get a circle shape actually. So anyway, it is very easy to recognize this one. This one, if you see this is half wavelength, and that is nothing but this is half wavelength, and this one is 1/4. This is lambda by 2. Again half of that, you join them, you get this one. So this is lambda by 4. This is lambda by 4. So this plus this again gives, you see only top side, students, so that you will understand. Top side, only top side you will see. And don't see here bottom one. This only this one. This is half wavelength. Then half of that you cut this here. This half here, this half here. So this is lambda by 4, this one, and this is I will draw like this. This is lambda by 4, and this is also lambda by 4. Now you can see here this one is lambda by 4. This one also, don't consider this line and this line. This line both are same. It keep going like this. So this line both are same. This is actually lambda by 4, one line if you take like this. This is also lambda by 4. Lambda by 4 plus lambda by 4 becomes lambda by 2. So that is M is equal to 1 half wavelength. Similarly, this line is also lambda by 2, lambda by 4, total lambda by 2. So N is equal to 1 half wavelength. So this is the TE-MN mode and TE-11 mode. So you can easily recognize for TM modes, fields will be circles like this. That is easy to recognize. So here you see in this direction, this is half wavelength, this plus this half wavelength, that means M is equal to 2. This one only 1/4, half wavelength is there, N is equal to 1. So TE-MN mode, here M is equal to 2, N is equal to 1. And you see here half wavelength, this half, so M is equal to 2. So TE-MN mode and TE-M is 2. This is half, 2 half wavelengths, this is 1, 3. So M is equal to 3, this one. Now TM excitation, actually this excitation is not that much important. These modes also they will ask rarely. Anyway, see, वो ज़्यादा पूछता नहीं है. देखिए, you take this waveguide and for TE excitation you will be exciting from here or otherwise here or otherwise here. Here you can put. But for TM mode they will drill a hole here, students. They will drill a hole here. Here they will drill the hole. and then if you drill the hole here and insert this one, so then it comes like this inside, like this I have shown, like this it comes. Then this is antenna probe. Then here magnetic field comes in the form of circle, because magnetic field lines are closed lines. I told you that electric field lines are shown as solid lines, these solid lines, solid, and electric field lines are shown with dashed lines here. These are dashed lines. Circular magnetic field is a closed line, circular lines, but shown dashed line. Solid line is there, means that is electric field, like this dashed line. So student, that's why in the textbooks they write like this, electric field lines, solid lines, magnetic field lines they show with dotted lines. So here if the probe is like this, then here magnetic field lines are circular lines, and if single circle is there, that is you have to take m is equal to 1 here. In this entire width, in this entire x direction, you have one closed line, so m is equal to 1. That means here one probe is used. So n is equal to 1, that is TM-MN mode. So TM11 mode, that is. For example, here two probes are there, you see. Here it is inserted one probe like this, and beside that one more is there like this. And of course these calculations are there lambda by 2, then only without reflecting signal it will enter into the waveguide. Here one and here one, the distance between them should be lambda by 2. Nobody will ask all those things. So that here, because of this probe, here magnetic field lines are circular, they spread, and here also because of this probe magnetic field lines are circular, they spread. So this is here one circle, two circle, so m is equal to 2. Here overall in this height you have only 1, so n is equal to 1. So that mode is TM-MN mode. So TM, m is 2, n is 1. So here if you see this one, in this case side by side they are like this, but in this case like here bottom top, like this, this bottom and top, right, 1 upon 1 here. This is one probe, this is second one, 1 upon 1, but here side by side they are. So in this case here only one circle is there here, so m is equal to 1. Here 1, 2, so n is equal to 2. This is TM-MN. So TM-M is 1 and n is 2, students. So this is the way you recognize the you answer the questions in examination. Okay. So students, circular waveguide, CWG, circular waveguide is a hollow metallic means conductor, student, very good conductor. Actually we want perfect conductor, but available is very good conductor, metallic pipe of circular cross section as shown below. I have shown you that if you take a sheet like this, conductor sheet, you put that in circle form. This is conductor, then this is the input end, this is output end. It is kept like this. The radius of this is small a. It is in z direction now, and if it is in z direction, then we are going to, this is cylinder cylindrical cases are solved in cylindrical system. In cylindrical system, parameters are rho, pi, z. Then electric field components are E rho, E pi, Ez. Magnetic field components are H rho, H pi, Hz. So this is cylindrical system. Now here this is the cylindrical waveguide, and this one is actually z axis, and this is small a, and this one is a conductor surface. This is conductor surface. So this is called circular waveguide actually. Okay. This is all, no students. This is like this. This is all conductor surface only. Like this. This is conductor surface. Now if you see circular waveguide equations are solved in cylindrical system, that is rho pi z system. Okay student, cylindrical system. For example, electric field, for example, let us talk of TE modes. So here we say TE NP modes. Here integer, N is integer, P is integer. Like that it is used actually, NP modes, like that it is used, NP modes. So here na, this is open end here, I am writing here. This end is open end. This is also open end. The open ends are in z direction, so wave travels in z direction. Wave travels in z direction. So for wave traveling in z direction, by definition of TE mode, EZS is equal to 0 and HZS not 0. Earlier I told you na, in circular rectangular waveguide, for TE modes, HZS is the main component that generates other electric field components. So here HZS is main component which generates E rho comma E pi components. Students, E rho generates H pi, then E rho and H pi carry the power in z direction. Similarly, E pi generates H rho, then E pi and H rho components can carry the power in z direction. But electric field z component is not there, because by definition of TE mode, electric field z component should not be there. So which generates these two components. Now students, actually I want to tell you one thing. Rectangular waveguide, circular waveguide, physically if you see, mechanism is same, but shape is changed. Because of shape change, rectangular waveguide, XYZ system, that is rectangular waveguide, rectangular coordinate system, it is solved. Circular waveguide, circle shape, concept, everything is same. Circular waveguide, circle shape, circular coordinate system you have to solve. In rectangular waveguide, rectangular shape, rectangular coordinate system you have to solve. That is why Ex, Ey, Ez are the fields. Hx, Hy, Hz. Circular waveguide, circle shape, circular coordinate system, and the components are E rho, E pi, Ez, H rho, H pi, Hz. Like that. So if you see here, students, then E rho, A rho, then I told you electric field rho component generates H pi, A pi, then pointing vector direction, then E rho, H pi, A rho cross A pi is actually Az. That means power flows in Z direction. Second case, pointing vector is equal to that pointing vector no here, E cross H. E cross H, that is pointing vector. So pointing vector is E cross H. So here open, that means EM wave enters this and out comes out of this. So wave travels in Z direction. Then electric field pi component cross, then magnetic field rho component. So here E rho, E pi, H rho, what is this? Rho, no? Then electric field pi component generates magnetic field rho component. A pi cross A rho becomes minus AZ, right? Minus AZ. Then one of them will have opposite sign. So ultimately, for example, for this you take minus, and you will have once again this one is AZ. So dear students, A rho cross A pi is AZ. A pi cross A rho is minus AZ. I told you same as previous discussions, either E pi or otherwise H rho, any one of them will have minus sign, they have opposite sign. That is why once again power is carried in Z direction. That is the concept of this one. So anyway, now continue the discussion because we have to study in exam point of view. Earlier I was teaching this also in depth. Before 3 years, microwave engineering was there. I was teaching. In the microwave engineering, this was discussed. This I used to discuss in detail. But here for a GATE examination, it is included. Here formulas are only liquid. You have seen in rectangular waveguide. Ultimately, what is important in rectangular waveguide? In rectangular waveguide, FCMN, beta G for MN mode, guide phase velocity for MN mode, guide wavelength, impedance. Only those formulas are important. We will solve the questions in rectangular waveguide. All the questions are based on those formulas only. Here also, our focus is cutoff frequency formula, beta G formula. Those formulas we have to see. So the discussion will be to write those formulas. So, and that too, no, it is very easy. If we write cutoff frequency formula in the circular waveguide, then all other formulas are exactly same as rectangular waveguide. So cutoff frequency formula only changes. Then beta formula, velocity formula, guide wavelength formula, impedance formula, all will be exactly same as TE and TM modes of rectangular waveguide respectively. So our focus is on now, we are discussing, our focus is on getting the formula for cutoff frequency. If you remember the cutoff frequency formula, then it is done, it will be over. Okay. So HZ is his main component which generates E rho, E pi components. Okay. Among E rho, E pi components, E pi is tangential to rho is equal to a cylindrical conductor surface. Rho is equal to a cylindrical conductor surface. I will show you what I am telling. For example, if you take this, this is Z axis. Now, what I am telling you is that this is rho is equal to a cylindrical surface. Here, rho component means like this in rho direction. That is normal actually. That is, I will draw one diagram here so that I will tell you that is normal actually. So, this is Z axis. This is rho is equal to a. Electric field rho component will be in rho direction like this. That is 90 degrees to this surface. But electric field pi component means that is like this only. Electric field pi component means it is circular. Okay, students. So The rho means radial, that is 90 degrees to this rho is equal to a cylindrical surface. E pi means that is circular, that is actually parallel or otherwise tangential to the rho is equal to a surface. So this E rho is radial actually, 90 degrees that one. So already we know student, all the concepts of conductors are applicable here. Already we know near the conductor boundary, tangential component of the electric field is 0. So near the conductor surface, electric field tangential component, is 0. That is E tangential is equal to 0 near conductor surface. So this statement is applicable for any case. This is general discussion, this one, not only for circular, for anywhere. So near conductor surface, electric field tangential component is 0. E tangential is 0 near conductor surface. Here what is written, you see carefully. Among E rho and E pi components, E pi is tangential to rho is equal to a cylindrical conductor surface. You got the point? Cylindrical conductor surface. What is the radius of that cylindrical conductor surface? Rho is equal to a. Now this tangential, which component is tangential? E pi. Okay. So now in circular waveguide, after solving the electric field equations for TE mode, then we get electric field pi component is proportional to the Jn of xc, kc, not xc, kc or otherwise beta c. What is kc, student? Beta c. What is beta c? Cutoff phase shift constant. Beta is equal to omega root mu epsilon, and beta c is equal to omega c root mu epsilon. That is nothing but kc multiplied with rho dash. What is Jn of some x? What is Jn of x, student? Nth order Bessel function. For example, Jn x, here x is there. That is nth order Bessel function. Dash means what? First derivative. So after doing derivations, we get electric field pi component in circular waveguide is proportional to the first derivative of nth order Bessel function. Here kc is cutoff wave number, rho is variable here for the circular waveguide. Rho varies from 0 to a, but near the conductor surface rho value is fixed, that is a. Student, here for circular waveguide rho varies from 0 to a, but for cylindrical surface, cylindrical conductor surface, rho value is a, that is fixed. I mean for conductor surface, no, I can show you here that for this conductor surface, if there is a conductor surface like this and conductor surface is this one, for this surface, for example, rho is equal to 2 meters, then this surface has a radius constant that is equal to rho is equal to 2. The 2 is constant. But inside this cylinder, for center radius is 0, radius is variable here. Now once again, continue the discussion here, where Jn dash of kc rho is first derivative of nth order Bessel function. Nth order Bessel function. Student, nothing is coming in the box. Nothing you have to remember for exam. This already you know. Whatever you have to remember, that I will put in the box. Okay, only that thing you have to see. We have to see the cutoff frequency formula. Right. Now, here what you have studied, for a conductor surface, electric field tangential component is 0. Here what you have studied, E pi is tangential to rho is equal to a cylindrical conductor surface. That means electric field pi component for rho is equal to a cylindrical conductor. That means shape is cylinder, material is conductor. For cylindrical conductor surface, E pi is tangential and near conductor surface E tangential is 0. That means electric field pi component at the rho is equal to a cylindrical conductor surface is equal to 0. That means E pi component is proportional to this one after derivations. So Jn dash Kc, you have to substitute rho is equal to a in this, is equal to 0. This is equation number 1. So this is similar to this Jn dash of x. Similar, na? This is. So equation 1 is similar to equation 1 is similar to equation 1 is similar to equation 2. Let x is equal to x dash np is the solution. Actually they are floral actually, not is, okay. R mandala floral, you can change np values, is solution of equation 2. Equation 2. Then equation 1 and 2 are similar. So equation 1 solution is also x np dash. That means what I am telling you is that this first derivative of nth order Bessel function is 0 whenever Kc into A is equal to x np dash. These x np dash are roots of this Bessel function. I will write that there. So here x Kc into A is equal to x np dash actually. Here of course this is the main formula, we will modify that. So here x np dash are the roots of first derivative of nth order Bessel function. This is dash means that is first order, n means dash means first derivative of n means nth order Bessel function, that is. Now coming to this is equation number 1, 2, 3. This is equation number 3. Here dear students, it is like this. This Kc is nothing but K is omega root mu epsilon. Kc means omega c root mu epsilon. That is nothing but beta. So this is nothing but beta c. In some books, K is named as beta. So here that is 2 pi Fc root mu epsilon. That is nothing but beta c Kc. What is Kc here, student? Kc is cutoff wave number. You remember this one, because now I am going to write the formula shortly. You have to remember that one. So now which one? This one? Okay, or this one? Okay, this one. 4. I will substitute equation 4 in 1. Put 4 in 1. Previously also we have studied this. Same thing only here also. Then Kc is nothing but this one. 2 pi Fc root mu epsilon is equal to xnp dash. Now from this Fc is equal to 1 by 2 pi root mu epsilon x np dash. Something is missing. Yeah, here A should be there, na? Kc is this one, but A also is there here. So from this here comes A, right? Fine. 2 pi Fc root A. Okay. Now, okay, students, Fc np is equal to 1 by 2 pi root mu epsilon, that is equal to root of xnp dash divided by A whole square. So remember this formula. This is the formula already in the books. Actually, this is the equation only, student. This is the equation, but this is an expansion form. From this only we got this one, student. In some books they ask you to remember this one. ये कुछ बुक्स में ये याद रखो करके बोलते रहता है, बट ये चीज है, ये शॉर्ट फॉर्म में आ गया. Then you know, students, why I wrote this root of xnp dash by A square? That is the reason. This is circular waveguide, student. Circular waveguide. Now for rectangular waveguide, Fcmn is equal to 1 by 2 pi root mu epsilon, then m pi by A square plus n pi by B square, and this formula was there for rectangular waveguide. So to maintain the similarity, it is written like this: 1 by 2 pi root mu epsilon, 1 by 2 pi root mu epsilon, m pi by A whole square, n pi by B whole square. Have you seen? X direction coefficient, Y direction coefficient, two coefficients are there, square is there, but in cylindrical system x square plus y square is equal to rho square. X and y combined to radius here, that is why single term came, radius term, rho is equal to A, radius term came, whole square root. Here m n integer, and here also np has integer. Now this is the cutoff frequency formula. You have to remember, dear students. All other formulas are exactly same, dear students. So this is a rectangular waveguide, this is circular waveguide cutoff frequency. Now let us write one by one. So here you know what is this is A is radius of circular waveguide. So D is equal to 2A diameter. Sometimes they ask you in terms of diameter of circular waveguide. Next, xnp dash, this is the thing you want. This one, xnp dash. Dash means what, students? First derivative. N is integer, p is integer. Here first root, 0th root means there is no root at all. P0, that means 0th root. P1 first root. P integer 2, second root. So p is equal to 3, third root. P0 means 0th root. How will you get 0th root? It is meaningless. So here p is integer. P can go from 0 to 1, 2, 3 like that. P0 means 0th root. 0th root. वो possible नहीं है. इसका मतलब वो mode exist नहीं है. So p is equal to 1 first root. P is equal to second root like that. So here pth root of first derivative of nth order Bessel function, this one. So that means for which values here if you take this as a x and p x, then for which values this first derivative of the nth order Bessel function becomes 0, and those values are this one x and p dash. So this is called pth root of first derivative of nth order Bessel function. So dear student, p is integer, that means number of roots, that is pth root of dash means here first derivative, n means of the nth order Bessel function. So these are the things in this, remaining things you know. So here students, one table is there for this. I will write the table, but you need not to remember all the roots. I also don't remember because it's not required. So you can see here, whichever root has least value of x and p dash, in the numerator least value, then fc is least value, that will be the dominant mode. If a high value is there in the numerator, this is also high value, that is not called as a dominant mode. So I am going to write the roots here. You see among those roots, which one has least value, you have to see student, least value. Anyway, here I will write this also. N is equal to 0, 1, 2, dash, dash, dash. It is integer. This is order of Bessel function. Anyway, you study these Bessel functions in communication, those things only. Now next, here p is equal to 0, 1, 2, dash, 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 0, 1, 2, 3, dash, dash, dash. It is integer root number, it is actually root number, and p is equal to 0 implies 0th root does not exist, which does not exist. Okay, just like that, mathematics says p0 means practically it doesn't exist, 0th root which does not exist actually. Okay, I will write the roots this side here. Roots of first derivative of Bessel function. Here you take integer p, right, like this. Here take an integer n. So n 0 here, n is equal to 1 here, n is equal to 2 here, like that. Next, p is equal to 1, p is equal to 2, p is equal to 3. Then this is 3.83. That means these are actually the values of x np dash actually. This value, this is x np dash. I will tell you example. This is 7.01, this root. 10.17. This is 1.84. This is the least one. 5.33, 8.53, 3.05, 6.7, 9.97. You can see it has least value, student. Now this is actually I will tell you what is the name of this one. What is the name of this one? Like this you write x dash n value is 1 for this, then p value is also 1 for this x dash 1 1 it is called as. So this x dash 1 1 mode is root name is x dash 1 1. This one first root it is for TE11 mode. So x dash 1 1 is equal to 1.84. That is the solution. So you put here x dash 1 1 is equal to 1.84. Then FC11 you get for TE11 mode. That is the dominant mode in circular waveguide. That is required. Students, you have to remember only this formula. This formula came from this. This and this both are same. And if you remember this formula, and after that, that root value, if you want, you can remember that is 1.84 value. This value is 1.84 for 1 1 mode. So FC11 you get that comes for TE11 mode. That is the dominant mode. So in the circular waveguide, dominant mode is TE11 mode. For that mode, this root value is x dash 1 1 is equal to 1.84. You remember that one. That is more than enough. Okay. If you want one value for TM modes also, you remember. But overall dominant mode is T11 mode only. Anyway, if you want to observe, next higher value is which one? After this, this one. This one. Okay, let it be like that. Right? You write this one here. I will write the statement also. Next, we have some work here. I will do like this. Then little bit marking is done like this. And I will write the mode name. This is TE0P. TE0P. One more statement is that TE mode, and here NP. Can you tell me N value is how much here? 0, and P is variable here. 1, 2, 3 like that. TE0P mode routes this. Let them be like that. Now you write the statement here. Dominant mode is the mode having least cutoff frequency. In circular waveguide, among all modes, this is applicable for TM modes also. You will see, we will write that also. Among all modes, TE11 mode at whenever x dash 11 is equal to 1.84. TE11 mode has least cutoff frequency. Least cutoff frequency. So in CWG circular waveguide, TE11 mode is dominant mode. Okay. Dear students, I told you what to remember here. Only one formula. FCNP is equal to 1 by 2 pi root mu epsilon XNP dash by A whole square under root, that is nothing but XNP dash by A only. But why I am writing root whole square? It is similar to the rectangular waveguide, two components, xy components, x and y together, x square plus y square is equal to rho square. Now it is merged into one component, radius component, already you know. So once if you remember this formula, then other formulas are same. In examination, you get the questions based on these formulas only, all questions. Now I am writing what is beta g? Beta g is equal to omega root mu epsilon minus omega root mu epsilon root of 1 minus fc divided by f whole square. Same formula, same as rectangular waveguide, but here the mode name is np mode. Here fc np comes. Other formulas are also same. Can you tell me rectangular waveguide formulas for TE mode? For TE mode rectangular waveguide formulas, beta g is known. Then guide phase velocity is equal to omega by beta g np. I will not write in expansion form. If you want, you can write. So this is for np mode. Okay. Of course, this is the formula. What after expansion you get v, that is the root of 1 minus fc np divided by f whole square you get where v is equal to 1 by root mu epsilon. Inside the circular waveguide, if dielectric has mu and epsilon, then that one. If inside the circular waveguide, if air is there, then it is mu naught epsilon naught, that is c. C means 3 into 10 power 8. Lambda g np is equal to 2 pi by beta g for np mode. This is the formula. Student, if you calculate this, you substitute this here, you get guide phase velocity. You substitute this here, guide wavelength you get. In expansion form, you want that is lambda divided by 1 minus root of fc np divided by f whole square, where lambda is nothing but v by f. Okay. So where lambda is v by f, that is c by f root mu r epsilon r. This is v. And eta g for TE NP mode is equal to eta g of TM MN mode, that is eta divided by root of 1 minus FC NP divided by f whole square, this one. So where eta is equal to root mu by epsilon. No need to put them in the box because they are exact same formulas as rectangular waveguide. I told you they should be same. Reason is rectangular waveguide shape is rectangle, circular waveguide shape is circle, and concept wise both have single conductor. Both are single conductor structures. So that is why they should be same. Formula should be same. Now I am asking you the question. Till now, what you have to remember? Answer only two things. One thing is this formula. Second thing is this one. TE11 mode is dominant mode at x11 dash is equal to 1.84. It is in the note. Anyway, I am writing all of them in the note. So here note is completed, student. Khatam ho gaya. Then TM mode means cutoff frequency formula is same, but xnp you get instead of xnp dash. There nth order Bessel function will get. Then others will be same, and but this formula will be n multiplied with root of 1 minus root of 1 minus fc by f whole square will be there. So that is the Tm mode, right? Tm Np modes in circular waveguide. Again, entire story you have to write that E pi component is present. After doing derivations, electric field phi component is proportional to Jn of Kc into rho, where Jn of Kc rho is nth order Bessel function, then that is 0 at rho is equal to a. That thing you have to write, we will be writing that one, right? So students, TMNP modes in circular waveguides. For wave traveling in z direction, for wave traveling in z direction, by definition of TM mode, electric field z component is not 0 as z is equal to 0. Here electric field z component, that is main component, that is like mother component, produces e rho comma e pi components. Among e rho comma e pi components, e pi is tangential to rho is equal to a cylindrical surface. Okay, next. After solving electric field equations in circular coordinate system, actually we have solved rectangular waveguide equations by taking Maxwell equations. We took Maxwell equations and solved in rectangular system. Same procedure, you take Maxwell equations and the del cross E formula, you write in rectangular system. Del cross E formula is 1 by rho, determinant of a rho a pi a z, dou by dou rho, dou by dou pi, dou by dou z, and e rho e pi e z. You solve that, then you will be getting the Bessel functions, and no need to do all the solutions. I told you in rectangular coordinate system also no use of solving the equations, that is wastage of time only. So after solving electric field equations in circular coordinate system, we get e pi is proportional to the nth order Bessel function Kc cutoff wave number. Rho is the variable. Here. So where Jn of Kc into rho is nth order Bessel function. Nth order Bessel function. Near the, it is written no already. Not written? Yes, written. Tangential component at rho is equal to cylindrical surface. So near the rho is equal to a cylindrical conductor surface, e pi is tangential comma on a conductor surface electric field tangential component 0. So here E pi at rho is equal to a conductor surface is equal to 0 and electric field phi component is nth order Bessel function, that is Kc into rho is equal to a. You have to substitute this equation number 1 here. The roots of equation 1 are x np. Okay, so Kc into a is equal to xnp. So this is the equation, and you can remember in this way also, in expansion form also. Kc into a is equal to xnp, and where Kc is nothing but omega c root mu epsilon, same as previous one, and this is Fc is equal to 1 by 2 pi root mu epsilon xnp divided by a. So how you remember this? Fc is equal to 1 by 2 pi root mu epsilon and xnp divided by a whole square under root, because it is similar to the rectangular waveguide. Now here xnp is pth root of nth order Bessel function. This is one thing. Next, a is a radius of circular waveguide. This is another thing. Then n is a 0, 1, 2, dash dash integer. The meaning is order of Bessel function. This is same as T mode. In T mode, x and p dash was there. Here x and p is there, and here p is equal to 1, 2, 3 dash 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 root number. It is the root number. I told you p0 means implies 0th root, which is not possible. Which is not possible. 0th root means there is no root. That is the meaning. 0th root means there is no root. That is the meaning. Now, what else to write? Table we have to write, na? From the table, we will be deciding if x and p least value, na, then that is the, what do you say, dominant mode. If this value is least value, then here that mode will be the dominant mode. Here you write, students, np. This is cutoff frequency for np. So I will write the roots here. You can see roots of Bessel function. Bessel function. I think in communication systems you will remember all these things, but anyway here not required. Nobody will ask you. So here p in this direction, n in this direction. So here n is 0, then 1, here 2, cross, no? Straight, right. Next, this is 1, this is 2, this is 3, dash dash dash. This is also dash dash dash. So in this, first one is 2.4, 0, because it is written like that up to 2 values. So 3.83, 5.13 and 5.52 students, then 7.01 and 8.41 and 8.65, 10.17 and 11.62, like that. So this one, no, this has least value of root, that actually this root is equal to, this is x, you can see here np, n value is 0 and what do you say, p value is 1, that is for tm, I will write here, that is for tm np, that means tm01 mode, that is. So among the tm modes, tm01 is the dominant mode, having x01 is equal to 2.40, that is the least value of the root. Numerator least value means least cutoff frequency. But have you seen in T modes, in place of 2.4, 1.84 we got. So you can make 3 statements. Among T modes, T11 is dominant mode. Among TM modes, TM01 is dominant mode. In a circular waveguide, among all the modes, TE as well as TM modes, least cutoff frequency is for T11 mode. So that is the dominant mode. Anyway, you remember this one also, that not that much important. पिछले वाला में टेबल में, in the previous table, I wrote like this. I wrote like this, students. Then can you tell me what is this? T M 1 P, because n value is 1 and P is variable. So in previous one, TE0P and here TM1P, both have same cutoff frequencies because roots are same. That is why they are degenerate modes. If roots are same, then cutoff frequencies are same. They are called degenerate modes. I will write that in the note. Once again, students, coming to the here now, this has least root value. So this is the dominant mode. TM01 is the dominant mode. Is it visible to you? I will write with the black ink. TM01. TM01. TMNP. N value is 0. P value is 1. That again, no need to write that separately. Now once again, other things are same. Formulas. FC NP is equal to 1 by 2 pi root mu epsilon, and this is XNP by A, and if you want to put whole square, then root you have to put, this is the one. Then students, what else? Other things will be coming in the sequence. Beta G is equal to omega root mu epsilon root of 1 minus FC by F whole square. If you put NP here, FC NP, here also NP. Then BG is equal to omega by beta G, same as the previous one. You put NP here, then here also NP you get, that one is V divided by root of 1 minus FC NP divided by F whole square, where same as previous, just I am writing for the sake of continuity. If I don't write, you will be confused. So lambda G is equal to, this is 2 pi divided by beta G NP. So that is lambda divided by root of 1 minus FC NP divided by F whole square, students. Now this is the changing formula compared to T mode. Eta G for TE, here TM NP mode is equal to eta divided by eta multiplied with, in the T mode it is in the denominator, in the TM mode it is in multiplication, root of 1 minus FC NP divided by F square. So this one you remember, students. Same as rectangular waveguide only. In rectangular waveguide also for TM mode, this factor was in the numerator, where eta is equal to root mu by epsilon, that is nothing but 120 pi root mu r epsilon r. So these formulas are same as um, T modes. So till now, how many things you have remembered? I am telling you how many things you have to remember. For in circular waveguide, for TEMN mode, the dominant mode is TE11 mode whenever x11 dash is equal to 1.84. If you want to remember for TM mode, that is TM01 mode when x01 is equal to 2.4 value, but nobody will ask this one. Then in the TE mode, cutoff frequency FCNP is equal to 1 by 2 pi root mu epsilon XNP dash by A. XNP dash by A. After that, remaining formulas like beta G, Vg, lambda G, eta, those formulas are same as rectangular waveguide. So no need to remember. That much only you have to remember, students. So in the TM mode, if you want cutoff frequency formula, 1 by 2 pi root mu epsilon XNP by A. Actually, in examination when they ask questions, they give the root value also they give, student. Root value also they give. They expect you to remember this formula only. Now I will write some important points in the rectangular and circular waveguide by comparing. So you write that in the note, student. So here you have seen TM1P, TM1P, and in the previous table also I kept around they are TE0P. They have same cutoff frequencies. That is why they are degenerate modes. Here I am writing a note. You remember those points. Field configurations, I will write in the note field configurations. Field configuration means shape, students. This is circular waveguide mouth. Then if electric field is like this, you remember this one. Remember, yaad rakhna ye wala. So this is TE11 mode, that is the dominant mode, right? Then this is circular waveguide. If field lines are like this, like a cycle wheel spokes, like this, this is the TM01 mode. That is the dominant mode here, TM01 mode. These two things you remember, that is more than enough. So if they give diagram like this, that is TM01 mode. If they give diagram like this, that is TE11 mode, you remember. So this is one note. So this is note 2 is like this. So like this. Okay, little bit. Yeah, little bit like this. This is Y. Little bit slanting I will do, because we have to merge that with the circle. Okay, this is Y, rectangular waveguide, student. This is X, rectangular waveguide. This is B height, you know that. Of course, this is A. Okay. Now, just like this it is shown. Of course, even though it is shown like this, so they will show like this, student. This is the circular waveguide. Circle shape come like this. So this is like this. Actually, there is a इसको ऐसा ही दिखाता है बस. It is shown like this. there is one rectangular waveguide and there is one circular waveguide here, and both are joined here. Now what is the question? Question is at the input of rectangular waveguide, if TE10 mode is sent, then at the output of circular waveguide dash mode comes out, then answer is this is dominant mode. So they will show like this field components like this. That is actually input TE10 mode for rectangular waveguide, because A is greater than B. Then output side also field component will be like this. They will be coming, and this mode is nothing but dominant mode here. So TE11 mode, dominant mode. So answer is TE11 mode you get. So you remember this one. There are so many cases, but this is important. So TE10 mode is sent at input side, then output side, this is output actually, this is input side. So this is input. So at the input of rectangular waveguide, if TE10 mode is sent, then at the output of circular waveguide dash mode comes out, then TE11 mode comes out. These things you remember. This cycle wheel spokes, the configuration is TM01, and this vertical line. But whenever what do you say, cylinder, when these electric field lines come near the cylinder, they keep bending, and ultimately when they come parallel to this, that electric field becomes zero actually, because the tangential component of electric field is 0. So this is T11 mode. You remember that. Okay. And now few points I am writing here in the note by comparing the circular waveguide and rectangular waveguide. Okay. So this is not rectangular waveguide and circular waveguide. So here first point is already you know many things. FCMN is equal to 1 by 2 pi root mu epsilon and m pi by a whole square plus n pi by b whole square root. FCNP it is called here 1 by 2 pi root mu epsilon, and then XNP dash by A, this is for TENP mode, right? And this one FCNP is equal to 1 by 2 pi root mu epsilon XNP divided by A for TMNP mode, right? This FCMN here is same for TEMN comma TMMN modes. This is the first point regarding cutoff frequencies. Already you know this one, right? Second point. Here the dominant mode, already you know, TE10 is the dominant mode if A greater than B in rectangular waveguide. TE01 is the dominant mode if A less than B. This already you know. Second one, here also you know. The dominant mode is TE11 mode. TE11 mode when x11 dash is equal to 1.84, right? Then third point regarding evanescent modes. Evanescent modes means what, student? Modes which does not exist or modes which have attenuation, both are called evanescent mode. Evanescent mode means modes which does not exist. Modes which have attenuation, alpha should be there. That means evanescent mode means modes. So dear students, now dominant modes we have seen. Now evanescent modes. Evanescent mode means the mode which does not exist, or otherwise another way, mode enters into the waveguide but because of attenuation immediately disappears. Both are called evanescent modes. Evanescent means modes which does not exist. Already we have discussed in rectangular waveguide TE00 and TM00, TM0N, TMM0, because here either M0 or otherwise N0, both 0, then power cannot be transferred. That is why these are the evanescent modes. Here already we have seen P0 means 0th root does not exist. That is why actually here TENP mode, TMNP mode, in both of them if P0, then that root does not exist. So that is why they are evanescent modes. Now degenerate modes, that means modes having same cutoff frequency. In rectangular waveguide already you have seen, for rectangular waveguide A not equal to B for rectangular waveguide. Okay, in that case TEMN and TMMN have same cutoff frequencies. Already we have written in rectangular waveguide, so that is why they are degenerate modes. For square waveguide already we have written in rectangular waveguide chapter that TEMN, TENM, interchange them, TMMN and TMNM. For square waveguide A is equal to B, so for square waveguide, okay, that is why they are having the same cutoff frequencies. So they have 4 some square degeneracy. I wrote in the rectangular waveguide chapter, but for comparison purpose we are writing. So already I have put 2 big circles in the roots table of T modes and in the roots table of the TM modes. There you have seen T0P, TM1P have same root values, so they have same cutoff frequencies, so they are degenerate modes. Coming to the modes in increasing order of cutoff frequencies, there are 2 cases in this. This is the case generally used for rectangular waveguide A greater than B and A less than 2B. Na? I told you, na, I will be solving this in the workbook questions. So there we will solve. For this case, TE10 has least cutoff frequency, after that TE01. Then TE11 mode, they are degenerate modes, TE11 and TM11. Then TE20, then TE02, because this is the order in increasing cutoff frequency for rectangular waveguide. In circular waveguide, you see both the tables. If you see the both tables, then TE11 has a least value for the root. After that TM01, and in the same table if you see carefully, then 3.05 is the next higher value. Then next higher value is 3.83. This value is same for x-01 That means that is TE01 mode, and X11 for TM11 mode, because X dash roots are for T modes, X roots for TM modes. So these are the things you have to remember. Actually, you have studied a little in depth only circular waveguide. Newly introduced this one. Maximum question will be from the cutoff frequency formula only, and is very easy. Okay. So, dear students, now let us solve the questions. Write the question. A TE11 mode is propagating, that is dominant mode in the circular waveguide, is propagating through a circular waveguide. The radius of the circular waveguide is 5 centimeter. The radius of the circular waveguide is 5 centimeter. And guide contains air dielectric. That means meaning is it contains air medium as a dielectric medium. That is the meaning. Then part A, determine cutoff frequency. Part B, determine wavelength lambda g in the guide. Lambda g in the guide for an operating frequency of 3 gigahertz, right? C, determine the wave impedance. Determine the wave impedance eta g in the guide. Okay, this is the question. Now, circular waveguide, so it is TE10 mode, TE11 mode is the dominant mode. It is given. The radius A is equal to 5 centimeter, right? It is 5 centimeter. And the guide contains air medium. Then determine the cutoff frequency. So students, what is cutoff frequency formula? FCNP is equal to 1 by 2 pi root mu epsilon, but for air medium mu naught epsilon naught, x np dash divided by a. Actually root whole square I kept for easy remembrance. So 1 by 2 pi, and that is FC11 you have to find root mu naught by epsilon naught x11 dash by a. I kept root whole square. Okay. So FC11 is equal to 1 by root mu naught epsilon naught is C. C is 3 into 10 power 8 divided by 2 pi. This one is 1.84. Actually that value is 1.841, but I wrote only up to 2 decimals. 1.841, that is 1.84 we wrote. Now 5 into 10 to the power minus 2. So this value after calculation, it becomes 1.758 into 10 to the power 9 Hz. You can see cutoff frequency is 1.758, but here operating frequency is 3 GHz. So operating frequency is more than cutoff frequency. So there is a propagation. There is a propagation of EM wave in this, right? Now determine wavelength lambda g. So for that you first find beta g. Beta g is equal to omega root mu epsilon root of 1 minus fc np divided by f whole square. Now beta g for TE11 mode you need, then this is 2 pi f. Operating frequency how much is given here? 3 gigahertz. So this is one more step. Shall I write? Okay, I will write one more step. So 2 pi f root of mu naught epsilon naught 1 minus fc11 divided by f whole square. So 2 into pi into, here operating frequency is 3 gigahertz. So 3 into 10 to the power 9. This is 1 divided by root mu naught epsilon naught. So 3 into 10 power 8. Next, root of 1 minus fc is here 1.758 divided by operating frequency is 3 gigahertz whole square. Now this value beta g becomes 50.9 radian per meter. You see that calculation. Now lambda g is required. One more formula, lambda g is nothing but 2 pi by beta g. That means 2 pi divided by 50.9. So this is also in radian. Now you get 12.3 centimeter. That is lambda g. Next, part C, what is asked? Determine the waveguide impedance. So guide impedance for TE11 mode or otherwise TE, this is equal to, formula was j omega mu divided by j beta g. From this only jj cancel, and from this only you got eta by root of 1 minus fc divided by f whole square. If it is mn mode, you have to put mn np modes here. So np here, circular waveguide np. So you can put in this also or otherwise in this also. For example, eta g for TE11 mode is equal to omega mu divided by beta g for TE11 mode, that is equal to eta divided by root of 1 minus fc11 divided by f whole square. Because if you take cutoff frequency for 11 mode and here beta g for 11 mode, then you get eta g for 11 mode, right? Now eta g for TE11 is equal to, this is omega is 2 pi f and mu naught divided by beta g TE11. Just like that I am writing, students. Ultimately we can use this one here. For air medium, omega mu naught beta g. So that is 2 into pi into f is 3 gigahertz given. Mu naught is 4 pi into 10 to the power minus 7 because filled with air medium. Beta g is 50.9 radian per second. Radian per meter. How radian per second? Now this is equal to 465 ohm. This is the answer, right? We will solve one more question. So another question. Given air-filled circular waveguide has x11 is equal to 3.83. Okay. Do you know what is x11 means? That is for TM11 mode, right? Because a dash is there means that is T mode, a dash is not there means that is TM mode. Capital D is diameter of circular waveguide. Okay. Find lambda c for TM11 mode. That is the question. Now we know that FC NP mode is equal to 1 by 2 pi root mu epsilon, then XNP divided by A. So here it is given FC 11 mode 2 pi, right? Then air field means what, students? Root mu naught epsilon naught you have to take. So root mu naught epsilon naught. One more step I am writing because then I will substitute. So here x11 then divided by, actually TM11 mode na, for that root name is x11. If it is TE mode, then x1 x dash will come here, right? So A. Okay. Now let us substitute the parameters. That is 1 by root mu naught epsilon naught is 3 into the 10 power 8. Then 2 pi. Then x11 is actually 3.83. Then A is there. A is nothing but a diameter divided by 2. Because diameter means 2A. Right, students? Diameter is equal to 2A. 2 to cancel, you get A. Because that fellow wants answer in terms of diameter. Now ultimately here okay, I am keeping this like this only. Let us see equation number 1. Now what is required for us? You know that V is equal to lambda c into Fc, but for air field it becomes C, this one. C is equal to lambda c Fc, and this is 1 1, this is 1 1. Now for that mode you want lambda c11 TM11 mode is equal to C divided by Fc11. So this is equation number 2, and put equation 1 in 2. That means lambda c11 is equal to C divided by, this is already C was there, C divided by 2 pi, and 3.83 divided into 2 D. So CC cancel, 2 pi capital D divided by 2 also cancels, no? Okay, anyway 3.83 into 2, 2 cancel, pi into D divided by 3.14 divided by 3.8, it will be less than 1 only. So 0.82 D you get. So this is the answer, 0.82 D. Actually this is nothing but 0.82 into 2A meter. So this is the answer, students, right? Ultimately, students, you have to remember those formulas, then you can solve any question. Okay. So students, now let us solve workbook waveguide questions. Workbook questions. This is waveguide. Waveguide, chapter 5. First question: a parallel plane waveguide. Parallel plane wave guide. We have substituted na B infinity, B tends to, that one only. Waveguide of 2.5 centimeter separation has an operational frequency of 22 gigahertz. Calculate the wave angle. That means wave angle means theta. Calculate the wave angle if the guide is operated in first mode and third mode. That means find theta 1 and find theta 3. For first mode m is equal to 1, and for third mode m is equal to 3. Okay. So theta is wave angle. Theta is wave angle. Already we have seen na, angle between the EM wave and waveguide axis, that one. So for parallel plane waveguide, FCM is equal to V into M by 2A, right? So it is actually what is the medium? It is not given. Medium is not given means you have to take air medium. So medium type is not given. So it is air medium. Students, you remember in rectangular waveguides and here parallel plane waveguides, if medium type is not given, that is air medium. Generally in engineering service exams they do like that, but in GATE exam we clearly mention everything. So if not mentioned, then that is air medium. Okay. Then for air medium, for first mode n is equal to 1, then FC1 becomes here FC1 becomes C. C means what do you say, air medium, na, light velocity. Then 1 divided by 2A. So 3 into 10 to the power 8 divided by 2 into A is 2.5 centimeter. So 2.5 means 5 by 2 into 10 to the power minus 2. So that is actually FC1 is equal to 2 to cancel, and it goes 30 by 5, 6 gigahertz you get, right now, 10 power minus 1, then 30 by 5, so 6 gigahertz. Okay, next. Similarly, here you can write like this: FCM is equal to VM by 2A, na? Actually, I will do one thing. FC1 is equal to V by 2A. Then FCM is equal to here. FCM is equal to V by 2A into M. That is nothing but FC1 into M. Right. So FC 3 for third mode. FC3 is equal to FC1 into 3. FC1 is 6 gigahertz multiplied with 3, that is 18 gigahertz. Now sin theta m is equal to FCM by F. So here F is operating frequency, 22 gigahertz is given. Now sin theta 1 is equal to FC1 by F. So sin theta 1 is equal to FC1 is here 6 divided by 6 giga divided by operational frequency is 22 gigahertz. Then theta 1 is equal to sin inverse of 6 by 22. Then similarly sin theta 3 is equal to this one. M is equal to 3, you have to substitute. FC3 divided by, this is the calculation over, one calculation over FC3 divided by F. So theta 3 is equal to sin inverse of FC3 is 18 and 18 giga divided by 22 giga. So that is this is the answer, second calculation. Okay. Next, second one, calculate the single mode frequency range. Calculate the single mode frequency range. Calculate the single mode frequency range for a rectangular waveguide of, that means 3 by 4 centimeter means 4 by 3 centimeter means 4 centimeter by 3 centimeter. That is the meaning actually. This is A, this is B. Student, actually in rectangular waveguide, no, A by B or otherwise A is to B. is called as aspect ratio. You remember this one. Aspect means shape, student. Shape ratio. For example, A by B is greater than 1. That is rectangular waveguide. So broader dimension is A. A by B is less than 1. That is once again rectangular waveguide. Then broader dimension is B. A by B ratio is equal to 1. That is square waveguide. So it is called aspect ratio. Aspect means shape. So sometimes they may give that for in a rectangular waveguide aspect ratio is 4. Then you must know what is that aspect ratio. A by B is called aspect ratio, right? Okay, like this it is given means this is A, this is B. That means A is bigger. Okay, calculate the बीच में ही लिखा है कोई बात नहीं. Calculate the single mode frequency range for a rectangular waveguide of 4 by 3 dimensions, right? This is the question. Dimensions. Now this is the question. So have you seen what is the waveguide? It is not given anything means it is air field. So nothing is given na, air field you have to take. So air field rectangular waveguide. Next. Actually in the waveguides nothing is given means air field you have to take. Mode he is not talking means for example calculate cutoff frequency, mode is not given. That means automatically you have to calculate for dominant mode, right? So if A greater than B, then FC10 FCMN is equal to air field. For air field it is C by 2 root of M by A whole square plus N by B whole square, students. Now FC10 is equal to C by 2, here 1, so C by 2A it becomes. So 3 into 10 to the power 8 divided by 2, A is here 4 into 10 to the power minus 2. Okay, this value becomes 3.75 gigahertz. That is dominant mode actually. Dominant mode. Blindly don't solve every time FC10 dominant mode. Carefully watch this. A greater than B. Then only that is dominant mode. You have to see, check that also. In waveguides and rectangular waveguide, first checking you have to do what is the medium. Second checking you have to do whether A greater than B or B greater than A. Then third checking for which mode he is asking the calculation. These three things you have to check. So medium type you have to check. Then whether A is bigger or B is bigger you have to check that. Then for what mode he is asking the calculation you have to check that. Okay, this is dominant mode because A greater than B. Next, let us calculate FC01 actually, FC01 that is here C divided by 2 and this is 0, this is 1, 1 by B whole square is 1 by B. So C by 2B. So that is 3 into 10 to the power 8 divided by 2 into B value is here 3 into 10 to the power minus 2. So that value becomes 5 gigahertz, dear students. Okay, 5 gigahertz. So that is next mode. Next higher order mode that is. So now single mode frequency range. Single mode frequency range implies here least one is 3.75 gigahertz less than F less than 5 gigahertz. So this is the answer, right? Now question 3. I will write the question here. Question I will write here. Question 3. And solution we will do there. Calculate the arrange the modes. Actually, these questions are all formula based questions. You will not have much to understand anything. You have to remember formula and apply. Very simple. Arrange the modes in increasing order of cutoff frequencies in a rectangular waveguide when a greater than 2b and a less than 2b. So I told you I will tell you the sequence of modes while solving the workbook question. So this is that question. You have to remember this sequence also after solving. Okay. So you have to remember that one, student. So here we will do one thing. FCMN is equal to V by 2 root of M by A whole square plus N by B whole square, students. Right? That is one thing. Next thing is FCM0. You substitute N0, then you get VM by 2A. Now FC0N, and here you substitute 0, V into N divided by 2B. Okay. Now case 1. We will take case 1 and case 2. Case 1. A greater than B and also A greater than 2B. That is case 1. Case 2. We will calculate case 2. A greater than B and A less than 2B. We will see calculation. So I will take example here. Example. After taking example only we can solve. I will take B is equal to A by 3. That means B is equal to 0.33 A, students. So what is happening here? We can see here. For example, A is equal to 3 times of B. Right? If you want to compare, you see here. I will compare. I have taken A is equal to 3B. A is equal to A greater than B, I told you, and that is one thing. Second thing, A greater than 2B, I told you that A is equal to 3 times B. If I taken, this is also satisfied. A is equal to 3 times B taken, this is also satisfied. So that is fine. Now this example we are doing, let us see now. FC10 is equal to V by 2A, because 1 you have to put A value is it is there, but we will be substituting we will be calculating answers in terms of A only. Okay. Next, FC01 let us calculate. FC01 is equal to, in this 01, V by 2, 0, this is 1 by B, so V by 2B you get. Now you substitute this, V is equal to 2 into B is equal to A by 3, you substitute, then we get 3 into V by 2A. Actually FC10 is V by 2A. Let us solve every frequency in terms of V by 2A, that is the least frequency. Next, FC20. So FC20 means this is 2 times of this one, that means 6 times of this one. FC20, yeah, FC20 means 2 times of this one. FC20 you can put here also, or otherwise you put here only, no, that is no problem. FC20 means V by 2, M is equal to 2, this is 0, so 2 by A. Now that becomes 2 times of V by 2A, right? Next, FC11 I will calculate, FC11. So FC11 is equal to V by 2, and here 1 you put, 1 by A square plus 1 by B square. Now let us substitute here B by 2, let us substitute B in terms of A, so then 1 by a square, then b is equal to, I have taken a by 3, so that means 9 by a whole square. B is equal to a by 3, I put 3 by a, so 3 by a. 3 by a square, that means 9 by a square we get. Okay, 1 by a square plus 9 by a square. Ultimately, this value becomes 3.16 V by 2a. Next, now let us write the modes in increasing order of cutoff frequencies. Modes in increasing order of cutoff frequencies. So students, first least one is what? This one, FC10, that is TE10 mode actually. After that you see here 3 is there, here 2 is there, here 3.16 is there. So 2 is the least value. Then FC20, that is the TE20 mode. After that, what is least value? After 2, here 3 is there, 3.16 is there. So this is the least one. So FC01, that is actually TE01 mode. After that comes this one, that is FC11, that is TE11 mode as well as TM11 mode. Both have same cutoff frequency. Like that, you have done arrangement, right? Now here, if a greater than b and a less than 2b, here also we will take one example. I will take one example that b is equal to 0.6a, like this I will take. Students, you may ask me question, here also a greater than b taken. Yes, in rectangular way, we know it is standardized that a is taken as, it is designed, it is decided that a is bigger always. Okay, any one of them should be bigger. They have decided it as a as a bigger. Now in both the cases a greater than b only, but you can see here I have taken this one 0.33a less than 0.5a, that is here if you see b is equal to, b is less than a by 2, this is actually, if you see b less than a by 2, that means b is less than 0.5a. But here if you see here carefully, b greater than 0.5a, but definitely it should be less than a actually, in between that. So that is why here b value is more than 0.5a and again less than a only, because whatever might be this value, ultimately a is only bigger, student. For this case, once again you keep solving, ultimately you decide the modes. This sequence you have to remember, students. For this case, this is the sequence. Now for this case, let us solve. You know that FC10 is equal to, here this one FC10, or otherwise here we put FC10, V into 1 by 2a. Next, FC01, student. FC01 means this one. V into, that means V divided by 2 into B is 0.6a. Let us calculate this in terms of V by 2a, and this becomes 1.66 V by 2a it becomes. Okay. Next, FC11. FC11 is nothing but V by 2 1 by a square plus 1 by b square, that is V by 2 root of 1 by a square plus 1 by b square. B is 0.6a square. Okay. Now this value 0.6 into a square, this is. So this value becomes after calculation, some calculation is there. After that this becomes 1.943 V by 2a you got. Okay, V by 2a. So this is 1 into V by 2a, 1.66, 1.943. Next, FC20 you will calculate that is nothing but FC20 means in this you substitute. So V into 2 by 2A, that is nothing but 2 times of V by 2A. So you can calculate like this, students. So first 4 modes more than enough. That's why I am stopping there. So increasing modes in increasing order of their cutoff frequencies. Okay. First mode is FC10, that is TE10 mode. Okay. Next, one time, that is 1.6, 1.9, 2. Next, in the sequence only we got FC01, that means TE01 mode. Next is FC11, 2 times this is okay. So FC11, that is the TE11 mode as well as TM11 mode. Next one is FC20, students, 2 times this is. So that is for TE20. You are able to understand here. But a TM mode is not possible if either M0 or N0. TM mode only possible if both are not 0. So this is the sequence: FC10, FC01, FC11, FC20. Okay, that is standard actually, this one. So if you take these two conditions, automatically this is the sequence you remember for 4. This is the sequence you remember for 4. Okay.